Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over two really awesome concepts in object-oriented programming, and those are polymorphism as well as inheritance. These two work really well together, and I can't wait to show you a bunch of examples as to how these actually work hand in hand. This is building up on our previous video where we looked at the introduction to class syntax in JavaScript as well as the concept of object-oriented programming in general. So as the previous video kind of mentioned, there are these four concepts in object-oriented programming, and these are going to go over two of them, and we're going to go pretty deep into this. And I hope that this makes sense, because when I first learned this topic, especially the whole polymorphism thing, which is a very big word, quite the mouthful, I definitely felt quite dumb, actually, to be quite honest with you, because I didn't really understand what people were talking about or how it worked in very much depth at all. But I can't wait to actually show you, hopefully, what makes a little bit more sense to you than what I first learned when I actually went through this. Let's just go through it right together. All right, so to start, again, I just want to mention these four overarching ideas of object-oriented programming. So I mentioned in this video, we're going to go over inheritance as well as polymorphism, but there really are four main concepts, which are including encapsulation and abstraction. In the next video, we're actually going to go over a little bit about encapsulation, and I'll touch upon abstraction a little bit. However, as we'll see in the next video after the exercises, it's not easy to implement abstraction, specifically in the language JavaScript. It's a bit more tuned to other languages. However, I will mention it, and we'll see kind of some ways where we might actually be able to use it. So that said, let's just get right to inheritance and polymorphism. So to start, I want to bring back this concept that we looked at in the previous video together. And this was this idea of a fantasy game, right? So I mentioned that, like, wouldn't it be cool if we could have a fantasy game in the player, in the game, we have a player and an enemy, but we can have really many different types of players, right? So like these are classes in most fantasy games, and this is slightly different than the concept of classes in object-oriented programming. So you might have like a warrior class or a wizard class or an archer class or something like that. And you also would have different types of enemies, right? So you might want to fight an orc or a troll or a dragon or a very scary fish like I have over here. And these are all share the traits of having being an enemy themselves, right? And same with the players. They're all kind of a player, so they can all kind of like walk around. They can talk to each other. They can do different things that a player might do in a game. So I'd like you to keep this concept at the back of your mind as we kind of go through this video, because really everything kind of is trying to solve these problems, because we want to think of things in the context of objects and kind of the things, the state and the code and the logic that we kind of associate with these objects and how they interact with each other. So let's take a look at this to start. Now, over here, we have, let's take a look at warrior, for example, right? So warrior is a kind of player. And how we might implement this, right? So this is just one possible implementation is we saw in the previous video how a constructor works, right? So this is a class, in this case called warrior, and it has a constructor function. And then that constructor, in this case, has 5 parameters, right? And inside of the body of the constructor function, we are assigning those arguments to the actual instance of this, in this case, which is the warrior instance itself. So we can create different warriors, and each warrior is going to have their own name, HP, MP items, and shield, for example, in this case, right? So you might argue not all warriors have shield. What if I don't want to have a shield? But let's just go with this thematically for now, just so we can focus on the actual concepts from a programming perspective. So if you look at this, you're probably thinking like, okay, like this makes sense, right? This is pretty good. So how would you make a wizard? Right? I'd like you to think about that. If this is how we might make something like a warrior, right? How would we make a wizard? Okay, so once you've given that a thought, I'm going to propose something like this. Okay, so let's take a look at this. So on the left-hand side here, we have a warrior, right? And you can see the same constructor function that we just saw on the previous slide. So we have the name, HP, MP items, and then we have shield, right? And then we assign these all to the warrior. I just realized I forgot to add the shield here, so I should probably do something like this dot shield is equal to shield, like that, right? Sorry about that. I'll just add that in there just to complete it. But you can see that we're assigning all these things to the actual instance of the warrior. But for the wizard, right, over here, we have a similar constructor function, and the class is called wizard, and it has a name, HP, MP, items. But a wizard is slightly different from a warrior, right? A wizard, in this case, let's just say our wizards don't have shields. Okay, they have a wand, for example, right? So you can imagine like anything for a warrior. You're probably saying like, oh, well, they have a staff, or they have, whatever, runes or whatever it is. But let's just go with wand just to keep this example super simple. So if you look at this, right, I want you to notice something really interesting, right? And I've kind of hinted at it with the highlighting here, right? So what seems kind of off if you were to look at these two classes side by side like this? Like what just feels kind of weird? So what's kind of strange here is that if you look at this, these constructors up until here where I have highlighted, right, the name, HP, MP, and items, they're the same. Right? So we're kind of like duplicating that in this case, right? The only real difference here is a warrior has a shield and a wizard has a wand, right? So same thing is true inside the actual body. So there's a lot of kind of repetition going on here, right? So all this code is literally the same. Like we could have copied and pasted over, right? Now, as we kind of progress through programming together, what you're going to see is, generally speaking, if you see repetition in code or a bunch of like copying and pasting going on, usually something is wrong, right? Programmers generally want to be very neat and as little repetitive code as possible. And as you get better and better at programming, you'll start to notice this more and more, where once you see things that are repeated like this, you're going to think to yourself, there must be a better way. Maybe there's a function I can use, or maybe there's this other type of tool that I can use, and I can kind of get rid of this repetition and kind of simplify the logic here. So if you look at this, right, the name, HP, MP, and items are the same. So we're repeating it not only in the constructor here, but we're also repeating it in the actual body. The only real difference, right, is this has a shield and this has a wand, right? So that's kind of interesting. Now, you're probably kind of getting the point, but I really want to hammer this home. So let's go back to, so remember, we're trying to make these three, right? We're trying to make a warrior, wizard, and a bartender. So let's go with the bartender. Let's see what we get, okay? So here we go. So we saw these two, right? And again, I forgot to add my shield here. Very sorry about that. Let me just quickly add that real quick. This dot shield is equal to shield. Not sure how that happened. But we can see that the wizard and the class are the same from before, right? And then the bartender is the one that we've added. But again, right, what you'll see is that this part here, right, these upper kind of parts of this constructor function, the name, HP, MP, and items, are just repeated. And in the bodies of these, everything is repeated. But the only thing that's unique to a warrior is a shield. The only thing that's unique to a wizard is a wand. And the only thing that's unique to a bartender in this case is a mug, right? So this is kind of curious, right? That there has to be a better way for this, you're probably thinking. Like, why can't we just make it so they kind of share some of these things, and then we can only talk about related differences between these, right? So this is actually the central premise behind inheritance in object-oriented programming. Now, I kind of hinted at it over here, so I'm just going to bring this up one more time before we continue. If you think about this area on the left, the green box I have here, I mentioned that we have a player, but the player can be a warrior, a wizard, or a bartender, right? But at the end of the day, the warrior, the wizard, and the bartender are all just players. We can kind of say that if you are a warrior, you're also a player. If you're a wizard, you're also a player. And if you're a bartender, you're also one of the players, right? So maybe we have many different types of players, just like with the enemies, right? If you're an orc, you're a type of enemy. If you're a dragon, you're a type of enemy. And if you're a very scary fish in this particular context, you're also an enemy, supposedly, right? So when we have this kind of relationship, where we have all these different things that share all these traits, and we kind of want to make each one slightly specialized version of kind of the template, I guess you can think of, which is the player in this case, that is the ideal case for inheritance in object-oriented programming. So let's take a look at that. Okay, so here we go. This is our start and intro to really how inheritance works. So let's kind of set a good base, no pun intended. So over here, I'm going to propose that we're going to create a class that's called player. Okay, so again, think back here, right? We mentioned that we have, in this case, 3 types of players, but they're all a player at the end of the day. So if we come back here, let's just make a template for what it means to be a player at the very kind of base level. Okay, so in this case, let's take a look at this. So we have a class called player, right? And this player has a constructor function in this case, right? And we're going to put all those things that were the same across all of these types of players, warrior, wizard, and bartender, into the base player. Okay, so those things are the name, HP, MP, and items. If you notice that those were the 4 things that all players shared in common. Okay, and we're going to assign that to the instance of the player in this case inside the constructor using this. And we can, if we really wanted to, I don't know why I said enemy here. I think I should have said player. Lots of edits on the go. Sorry about that again. But we can create a new player like this, right? So we're passing in the name, the HP, the MP, and then the items. So if we think about this, this seems kind of okay. Right? Now, it doesn't really make sense if you really think about it, because we would never really want to create a player by itself without telling kind of our game what kind of player it is, right? Because what does it mean just to be a player? So this is one of the concepts that we're going to visit in the next video, which is called abstraction. So in theory, we'd actually want to make this what's called an abstract class, which doesn't exist in JavaScript, but it's one of the core concepts of object-oriented programming that I mentioned before. So I don't want to confuse you too much. Let's stick with inheritance and polymorphism in this video, and we'll touch on that later. I just want to have that at the back of your mind. So again, to recap this, we have created a base, or sometimes called superclass, okay, or parent class sometimes, where we have the name of the class, and in this case, the constructor function that has the base things needed to construct every type of player in kind of our world that we're creating, okay, or in our application. And in this case, we've decided that we want every player, no matter what kind of player you are, to have a name, HP, MP, and items, all right? And if we really wanted to, although it doesn't make much sense, we could make a player like this. Okay, so let's actually take a look at what this allows us to do, which is actually the premise for inheritance. So check this out. Okay, so there is a lot going on the slide, and we're going to code this out together in a second, but let's just go through this step by step. So on the left-hand side, I have our superclass, which is our player. Okay, and our player has this constructor, name, HP, MP, and items. This .name is a name, HP is HP, MP is MP, and items are items, right? So our player is always going to have those values. Now, what we've done here is we've created a second class, okay? And the whole point of us doing this was to reduce the duplication of code between these classes. So let's see if we've achieved that, right? So over here, I've created another class called warrior, but notice something interesting. I have added a new keyword here, and that is the one in pink right here, the extends keyword. So let's just read this single line out together and really make sure we understand what it means. I have said, create a class called warrior that extends the player class. Well, what does that mean? In JavaScript, what this means is that we want to take everything in player and we want to put it inside warrior, right? So technically what this means behind the scenes is we're hooking up all of the prototypes like we've seen in the previous videos, so that every warrior is going to share the prototype with player. Okay, so warrior is going to be its own independent thing, and the prototype of everything that has a warrior in it is going to also refer to a player, which is going to refer to object, which is going to refer to null. So we're going to have an inheritance chain going, or a prototype chain going, where we have warrior, player, object, and null. Okay, so when we say extends, what we're technically saying, you can think of it this way. The easiest way to probably think about this is that we're pretty much going to like copy and paste a lot of code from here into here so that we can kind of refer to it through the prototype chain. It's not really copying and pasting it because we're going to be referring up the prototype chain, which we'll see shortly, but that's really kind of the base premise of inheritance. Everything that a warrior has is inside the player as well, plus some new things that we can add if we want. So let's take a look at this because there's some kind of funky stuff going on over here. So a warrior is still a class, so we can add a constructor. Okay, but notice that this constructor is slightly different than this constructor over here. So this is the constructor for warrior. This is a constructor for player. The warrior constructor has all the things that the player constructor has. Okay, it doesn't have to, but in this case, we have the same things. We have name, HP, MP, and items, right? But we've added the thing that we want, which is shield. Now, you're probably thinking, wait, I thought we were trying to get rid of name, HP, MP, and items. Wasn't that the whole point of all this? So hold on to that thought for a second because it's a valid thought. Just for now, focus on the fact that we're passing all these things in. And then let's jump into the body of the function. And this is where the power and the difference really comes in for inheritance. So this is our subclass, which is warrior. Okay. And every warrior has everything that player has. Inside of a subclass, we have access to a new keyword. And this keyword is the super keyword. Okay. When we use the super keyword in a class, we are referring to the parent or the superclass. So we're basically referring to the thing that we're extending. That's why I've color coded these as orange, as you can see on the screen. Okay. So when we're talking about super, we're actually talking about player in this case, from the context of warrior. Okay, so when we call super like this, because we can actually call it like a function, which is really a shortcut for something, and I'll show you in a second, we're telling JavaScript, please go to player and call its constructor with the values that I'm giving you. So here you can see that we're telling JavaScript, go and call the constructor function inside of player, which is what super refers to, and pass it these arguments, name, HP, MP, and items. So we are grabbing those from the arguments passed into our warrior. Okay, so I'll point this out in a second when we look at the code below. So when we create a warrior, we're going to be passing it these 5 things. The first 4 things we're going to pass up to the parent, which is player, and it's going to call this constructor. And it's literally going to execute this code. That's actually what's going to happen. So this line right here, super of name, HP, MP, and items, is going to execute the constructor function inside the superclass, which is player. Okay, what is that going to do? That's going to set up this.name, this.hp, this.mp, and this.items. So if you think back here, right, we did all that manually here. Right? Or I should say here, I'm too excited about Bartender, right? We did all that manually here, but we were able to get rid of these 4 lines right here because we just called it in the superclass, which is actually going to do the setup for us. Okay, so we can take those 4 and replace it with this 1 line, which is basically copying and pasting this constructor into here. That's the way that you can think about it. Now, the superclass player doesn't have shield. Right? So that's the differentiating factor between a warrior and a player. So we still need to set that part up ourselves manually. We can't rely on the player to set up shield because player has no idea about shield. Only a warrior knows about shield. So that is why we still need to do this.shield equals shield inside the warrior class. Because when we create a new warrior, we're going to be passing in a shield, and we still want that to be set up on the this object. Okay, which is the instance of a warrior. So again, just to recap this, super refers to the superclass here, the parent. And when we call it like a function like this, and we can see other ways that we can use super in a bit, when we call super as if it's a function, we're going to execute the constructor function in the superclass. This is actually quite common across pretty much every single programming language. Okay, and then we can add whatever code that we want below it to set up what's unique to warrior. All right. So let's take a look at what actually happens here. So here, I mentioned this is enemy again. Oh my goodness, look at this. I'm getting sloppy with my my slides. So much going on. I got too excited with the arrows, I guess. So we can still create a player, right? We saw that previously. So that can still work, but that's not very useful for us, right? Because we want to be able to create warriors. So how would we create a warrior? Well, that's what I have down here. Check this out. We can create a warrior by calling our warrior class, which is calling the warrior constructor function. We can give it a name, HP, MP, items, and then now we can also pass it a shield. Notice we didn't pass in a fifth parameter or argument to our player because it only has four parameters, right? But our warrior has 5. That's why we can give it this fifth argument, which is in this case a leather shield, which is actually going to get assigned to this dot shield. All right. So now a warrior has everything that a player has, but it also has a shield, which is fantastic. So let's take a look at this in code together. I'm going to pull up VS Code and I'm going to create a new file here. I'll just call this subclass.js. All right. Let me zoom in a little bit more here. Okay, perfect. Now let's create our first class, which is player. So I'm going to call this class player. And inside of player, I'm going to create a constructor function. And inside of the constructor function, I'm going to allow it to have a few different things. So to start, let's just say, let's just kind of copy what we had here. Name, HP, MP, and items, right? So name, HP, MP, and items. And I'm going to assign these all to the this object. So I'm going to say this dot, oh my gosh, not history. This dot name is equal to name. This dot HP is equal to HP. You can see a lot of boilerplate code that we have to add here when we're doing some of this stuff. MP, this dot items is equal to items. So we are assigning whatever comes in as arguments to the actual instance using the this keyword, right? So we can create a player is equal to a new player if we want, and I can just give it a kind of some default values here just so we can see what that looks like. And maybe it has a banana or something. Every player starts with a banana, for example. Right? And if I console.log out player, let's take a look at what we get. So I'm going to get node subclass.js, and you can see that we have a player and it's got a name, HP, MP, and items. And we saw that in the previous video. So nothing new over there. All right. So check this out though. Now what we can do is we can extend on this. Okay, so let's say that we have something that is a player, but it is more than just a player as well. It has other things like we talked about with our warrior. So we're going to say class warrior. And this is the keyword that we need to keep in mind, extends our player. Okay, so technically what happens here behind the scenes is quite a few things, but effectively this is going to hook up warrior's prototype to be player. And we're going to have access to everything inside of player, inside of warrior. And we have a special keyword which we're going to look at in a second called super that actually allows us to refer to the superclass, in this case to player. So I'm going to create a constructor function in here. And I'm actually just going to copy these things over, which is name, HP, MP, and items. And I know I mentioned if you see copy and paste, something is a bit wonky, but bear with me for a second. And I'm just going to add shield. And now, normally what we do is we would copy and paste all this over. But I just mentioned that we can actually refer to our superclass with the super keyword. Okay, so let's just see what happens if we just leave it like this. Okay, so I'm going to say const warrior is equal to a new warrior, and I'm going to give it, let's just say, this is going to be our warrior. I know I had Genghis Khan earlier. Actually, let's just do this. Genghis Khan. Let's just say Genghis has, I don't know, a lot of HP, very strong, a little bit of MP, maybe not very good with magic or something. And Genghis, I think, had a had a saber and then a leather shield, right? So leather shield. All right. So my formatter is putting that on different lines for me. Now we can say console.log our warrior, and let's see what we get. Right. So we created our warrior, we created our player. Our warrior extends our player, right? And we didn't add anything about super yet. right? We just put in the constructor, and we're not actually really using it for anything. So let's just see what happens. So I'm going to rerun this file here, and you can see that we get an error. Okay, so this looks a bit scary, but the key is right here. All right, that I've highlighted. We have reference error, must call super constructor in the derived class before accessing this or returning from the derived constructor. So this is super important, and this is in many languages, but also is a few kind of tidbits specific to JavaScript. So we cannot create a subclass and then add our own constructor, but then ignore super. And the reason is that in order for JavaScript to hook up all the prototypes, it actually uses super to do that behind the scenes for us. So what we want to do is call super, which is calling our player's constructor. You can see right here, right, that we are calling player with our name, HP, MP, and items. Right? So you can think of this as basically almost doing like we're calling this constructor function. Is exactly what we're doing. So we're going to give it our name, we're going to give it our HP, MP, and our items. We are not going to pass in shield. In this case, it's actually not going to do anything because this is just going to be given as a fifth parameter, which will just be undefined. But this is not necessary, right? Because a player doesn't know about shield, right? So super refers to player in this case. So let's take a look at what happens if we ignore shield. Okay, I'm going to rerun this, but now we've added our super call, right? I'm going to run subclass and look at that, right? We have our warrior, which has a name, Genghis Khan, HP, MP, and our items. It doesn't have a shield because we never assigned the shield to this value for the player. So really in this case, there's no difference, almost no difference between our warrior and our player. They pretty much have the same things, it's just kind of they're named differently. Okay, so we're not actually using shield. Now, before I show you how to do this properly, I'm going to try to do this before the super call. I'm going to say this.shield is equal to shield. I'm going to rerun this code, and what you're going to see is we get the same error. We cannot use this keyword in a constructor of a subclass, right, or a child class before the super call, because the super call actually sets up all of that for us behind the scenes. So we actually have to call super first inside of a constructor in a subclass. So if I switch these around and I save that and I retry this, let's see what we get. Check it out. Right? Now we have exactly what we wanted, which is we have our base player, and we also have our extension of our player, which is our warrior, Genghis Khan, 500 HP, 50 MP, items is a saber, and then Genghis Khan's shield is the leather shield because we actually assigned it to this .shield right over here. Okay, so always call super as the first thing in the constructor of a subclass. Now, I want to show you one thing here as well. I'm going to do a console.log in here, and this is in the subclass, and I'm going to console.log super, or sorry, super.constructor. Okay, not just super. So there we go. I want to show you this as well. But if I do this, what we'll see is that we actually have access to the constructor of super. Of our superclass in this case, which is player, right? So this is literally referring to this function inside player. If we had other functions inside of player, other methods inside of player, we would also have access to them, and which we'll see next. Okay, so technically what's happening is when we call super like this, you can think of it as basically doing this, super.constructor, and then we're calling it like this. So don't ever actually do this because we have it set up in JavaScript to do it this way, specifically for the constructor function, but you can think of it as basically doing this. Okay, now one other thing I want to log, I'm going to get is right after the super here, I'm going to get rid of that other comment in there, is the this value. Okay, so I'm going to log the this value in here, and I'm going to show you what happens inside of the subclass before I show you what happens in the superclass. So if I run this, what you can see is that the this value right, is this object right here. So I should probably say this, just like this, and run this one more time just so we can take a look at what happens. And you can see that I get this warrior, right? Which sounds a bit funny, but we're basically logging the string this followed by the object this. So that's what this is right here. No punniness intended. So this is literally the instance of that warrior. Okay, and this is working as we kind of expect it to be, right? Because we've assigned all the things to this. You can see that this value has the shield on it. Check this out though. I want you to think, what's gonna happen, right, if I move this up before I assign the shield? Okay, this is quite tricky. If you can try to wrap your head around this, you're gonna get a really, really good kind of head start on how classes work. So let's run this one more time and check it out, right? So this warrior, when I move it before I assign shield to this object, doesn't actually have a shield yet, right? Because we haven't assigned it. So if you look at this code, it kind of makes sense, right? Because we're literally adding the shield property to this object after we've done this, or after we've logged it out. All right, so that's pretty cool. So I'm gonna move this kind of back down here. I'll get rid of my constructor call right there. And I'm going to put another console.log this in here as well. Okay. And this is in the player superclass. Now, I would like you to think, what do you think we're going to get logged in this case? This is super tricky again, but if you can understand what's happening and trace the actual flow of the code, remember what super actually does. Try to think what's going to happen in this case for this value here versus this value here. And I'm actually going to add player this just so that we can actually differentiate these. And I'll say warrior this over here. Okay. Once you've thought about that, maybe tried it out, I'm going to run this code. And what we'll see, so hopefully not cut off by my face over here, just barely, we can see that the player this right here is the warrior, right? And it has the name, HP, MP, and items, right? So it still is a warrior in this case, but it doesn't have the shield yet. Over here, we get the warrior this, which is also a warrior, but the main difference is that now it has the shield. Okay, so what is happening is kind of exactly what you'd expect to happen in this case. When we call super, right, we are literally running this code and assigning all these properties to this object, which is the instance of the warrior in this case. Right? Which is why when we log it here, we haven't actually had a chance to run this.shield yet, because that comes after the super call, which is just a call to the parent class's constructor. Pretty cool, right? Okay. Hopefully I'll let that sink in for a little while and then we'll keep going with this because I have a few more cool things to show you. Okay. So we've seen how we can kind of do a subclass, share a lot of the traits as a superclass. Right? And in this case, also the super word keyword itself, when used as a function like this, refers to the constructor function of the superclass. But check this out. We can actually take this concept and really ramp it up. All right. So if we have a superclass and a subclass, same as before, the only code I've changed on this slide is to the player itself, to the base class or the superclass, whichever phrases you like more. I've added a new method. Okay, and this method is the speak method, which takes a single argument called phrase, and it's just going to do a console log. It's going to say this.name says the phrase. Okay, now notice, the important thing here is that this method speak is on the player. It is not on the warrior. Okay, the warrior's code is the same as before. We're setting up the constructor, we're calling super, we're setting up the shield, and then that's it. We're returning to this object. So when we create a warrior here, Genghis Khan again, and all the different values, that works fine as expected. But what's really, really cool is we can call warrior.speak, right? And we can give it a phrase like come and sip from the cup of destruction, right? And we will actually get Genghis Khan says come and sip from the cup of destruction, lodge out, right? That is super cool. So if you think about why this is, every single warrior is also a player, and player has a speak function, or a speak method, I should say, right? Which means by definition that if a warrior has everything that a player has, that a warrior also has the ability to speak, right? So we can call any method inside of the parent class just as if it was on the subclass itself. So let's take a look at that in code together. So I'm gonna create a new file here, and I'll just call this, let's just call this parent method.js. I'm gonna copy over my two classes, okay, just so that we have a kind of a fresh slate, and I'm going to put them over here. Now, I'm going to get rid of the console logs here, right there and right there. I'm going to add that method, speak, inside of player, okay? And this is going to take the phrase, and this is going to console.log out. I'll just say this.name, and then says, and then phrase, all right? So if I create a warrior, actually, I'll just copy my warrior call from over here just so that you don't have to watch me type it out. There we go. Okay, I'm gonna copy over Genghis. So now I have my warrior. All right. What I can do is I can say warrior.speak, and I can give it hello, for example, right? That's not how you spell hello. That's how you spell hello. And if I run this file, all right, we're going to run node parent method. We're going to get Genghis Khan says hello, right? Not as cool as Genghis Khan says, come and sip from the cup of destruction, but that was too long to type out. So I hope you didn't get too sad about that. So that is super awesome, right? What we did is right here, we called a method on warrior that doesn't actually exist on warrior, but it exists on the parent of warrior, which is player. This works the same way that prototypes work in JavaScript. What's really happening behind the scenes is JavaScript knows that warrior is of type warrior. It's going to look at the warrior class. Is there a speak method on warrior? Well, there's not, right? We can see that there's only a constructor. So JavaScript is going to say the same thing as it does with prototypes. Okay. I'm not going to worry because I know that the prototype of warrior is player. So I'm going to look in player to see if there is a speak property inside of warrior. In this case, a method. And there is, right? It's right here. So it's going to use that. Now that is pretty awesome, right? So you can kind of see the links between prototypical inheritance, and object-oriented programming in JavaScript, and kind of how there's some similarities, but also some differences between them. Okay, that's pretty awesome. So let's keep going with this. So what else can we do with this? Well, take a look at this. I want to add one extra bit of coolness to this. So imagine that we wanted to actually refer to this function. As I mentioned, super refers to the superclass. If we call it as a function, by default, that means calling the constructor method inside of the superclass. However, we can actually refer to methods and properties inside of the superclass as well, just as you would probably expect. So I can say, for example, super.speak, and I can refer to the player speak method, okay, from inside of warrior. So this just allows us to reach into the prototype or reach into the parent class and grab anything that we need. And we'll see that we can actually hide things later when we look at concepts like encapsulation in the next video. But for now, let's just keep it simple and make sure that we understand what's happening here. We can not only refer to super's parent constructor, but we can also refer to methods as well as properties inside of the superclass. So in this case, what I'm saying is when you construct, oh my goodness, when you construct a warrior, right? What I want you to do, JavaScript, is make the warrior, call the constructor of player, add the shield property to the warrior, but also call the speak method in the superclass and give it a string of rar as the actual value. Okay, so when we create our warrior here, Genghis Khan, we're gonna immediately get, because this is in the constructor function for warrior, Genghis Khan says rar. Right? We can still use it normally. We can say warrior.speak and give it a custom phrase like come and sip from the cup of destruction, and we would get the same output as before. All right, so let's take a look at this in action in code. So over here, we had our player class and we had our constructor and our speak method on it. We had our warrior extends player. And now we want to see what happens when we try to access super inside of our warrior class. So let's take a look at what we can do here. So previously we saw that we could do super by calling it like this, which accesses the constructor inside of the superclass, but we want to see if we can access speak from inside warrior. So if I do this inside of the constructor for warrior, what I can do is actually reach up into the prototype, which is the superclass, which is player for warrior, and try to access methods on its prototype. So for example, if I do super here inside the constructor, I can do this really in any method, and I do a dot, I can access a properties on the prototype. So actually, now that I'm looking at this, this is actually not wrong. So I think my editor is being a little bit wonky here, and I'll show you what I mean in a second. So this is actually incorrect. It's giving me the incorrect suggestions. But what I want to be able to do is do super.speak here. And maybe I'll say something like rar, right? It's like I have in the slides. So what this is saying is go up to player. Technically, this is saying go up to player's prototype, right? Because speak is on the prototype for player. It's not directly on player. We'll see what that looks like in a future video. It's called static methods, and it's not on the instance of a player either. It's on the actual prototype. So it's literally on player.prototype.speak. Right? So I can access the prototype using super, and I can call this method and I can pass it a string, and it's going to call this speak inside of the player class. So let's take a look at what this actually looks like. So I'm going to run my code over here, and you can see, right, that we actually get Genghis Khan says rar, which is coming from right here, which is calling this speak method inside of the superclass, and then we get hello, which is coming from line 29, which happens after the constructor functions run from both the superclass in the super and the subclass here in warrior. So that's pretty awesome. So what I wanted to show you actually was incorrect was this, right? If I try to do super.high, I might have mentioned this earlier that we can access properties inside of the class. That's not entirely correct. So let me just correct myself here. What I'll get here is undefined, right? So let me show you why. So you can see that we get undefined for super.high. Because when we refer to super in this way from inside a subclass, we're not really referring directly to player, we're referring to player's prototype, right? So just to show you what I mean here, I'm going to do a console.log of object.getOwnPropertyNames of player.prototype. And I'm going to show you what's on here. So you can see that we have constructor and speak inside of the player prototype. And lo and behold, right? Those are these two methods, right? These are the two methods on the player prototype, which is pretty awesome. So if I try to do console.log of player, get property names of just player without the prototype, let's take a look at what we get. And we get length, property, and name. And don't get confused by this name. This is actually a different name. It's from the function name. It's not the same as this name right here. So this is actually a function. Okay, so we'll get into this in a future video, but this is really what we're interested in, and all of the methods inside of a class are on the prototype. So technically, if you really wanted to see how this works, and I can prove it to you, I guess right now, is if I come up here and I say player.prototype high, for example, which is what I'm trying to access, super.high is equal to hello from player proto, for example. Then what I'll see is instead of undefined being logged out, right? Let me rerun this over here. You'll see hello from the player proto, which is directly on the player prototype. So just be careful with this. In other languages, this works slightly differently. So JavaScript is a little bit wonky with the way that this works with the prototype chain and everything. So usually what we'll do is we're only going to access methods on the prototypes. We're not really going to be accessing these properties like this. Okay, so that is pretty awesome. So if that kind of went over and above, don't worry too much about it for now. The kind of main takeaway with super, using it apart from the constructor, is just use super to refer to methods on the parent class. All right, awesome. Now what I want to show you next is something pretty fancy dancy. But before we get to that, I just want to mention this extra keyword. I'm throwing a lot of keywords at you today in this video, so I hope it's not too overwhelming, but these are all kind of related to each other in the concept of inheritance and polymorphism, which we're going to look at next. So imagine that we have our class player, which we just saw. We have our class warrior, which extends player, right? So warrior is a subclass of player, or player is a superclass of warrior. We can create our warrior, for example, Genghis Khan. We can do this here in JavaScript. So just like in JavaScript, there's like this type of operator and then the in operator and things that we can kind of use on themselves that are keywords. We actually have another operator specifically meant to help us out with this class system. So that operator is called instanceof. Okay, and that's why I keep referring to these objects that we create from these classes using their constructor functions as instances, because that's what they are. So we can do something like this. We can say, once we've constructed our warrior instance, we can ask if that warrior is an instance of the warrior class, and we would get true or false from this keyword. What's really, really cool though, is check this out. This is the real power behind inheritance. We can actually also say warrior instance of player, right? And that's actually going to give us true. And the reason for this is that we're basically asking, is warrior a warrior? Yes, it is in this case, right? Because warrior is a new warrior, and then we give it all of the constructed properties. Then how about, is warrior a player? Well, it is, right? Because warrior extends player. So technically speaking, a warrior has everything that a player has and a bit more, right? So these two statements definitely make sense. It makes sense that they're true. So let's take a look at this really quick. If I come back here to my code and I do a console.log and I say warrior instance of, this is the keyword, right? Notice that my editor highlights it in a special color because it's a keyword, just like new, for example, and extends in class. And I can say, is warrior an instance of player, right? And what I'll get is I'll get true, right? I can also copy this and I can paste it one more time and I can say, is warrior instance of warrior? And both of these are true, right? Because it's true that a warrior is an instance of a player and a warrior, because warrior is inheriting from player. But for example, if I say, is warrior an instance of, I don't know, let's say an array, for example, right? This might look kind of strange. So if I do that, it will say I get false, right? Because it's definitely not inheriting from array. So the next question is, what do you think we're going to get if I say warrior is instance of object? All right, tricky one. Clear my console here, I'll try it out, and we get true, right? So this is kind of that concept that everything inherits from objects. So this really proves to us, right, that warrior is prototype is actually the player, but then player's prototype is actually object, and an object's prototype is the null prototype, right? So we can actually hunt up the prototype chain and ask these questions. And if it's in the prototype chain anywhere above, we're going to get true for it's an instance of that object. Okay, that's pretty awesome. This is going to become very, very useful for us when we start doing lots of subclasses, and even when we look at concepts like polymorphism, which I'm going to get to right now. So this next slide that I have is the last slide for this video, but also super, super key to understanding inheritance, because as I mentioned before, one of the pillars of object-oriented programming up here, right, is polymorphism along with inheritance. Now, this sounds very scary and very fancy, and this is one of those things that kind of blew my mind. I had no idea how to explain it when I first started learning it, and it took a lot of practice to really hammer it home. So I'm going to try to explain this hopefully as easy as I can, but it's really just going to take practice to really have it sink in over time. So here we go. Let's check it out. All right. So what I have over here looks kind of nutty. Okay, so just a forewarning, but I promise you that this one single slide that I have right here hopefully explains polymorphism, which is one of the central concepts of object-oriented programming. And we need to understand inheritance to also understand polymorphism. So let's take a look at what's happening here. Up here, in these first 4 lines of code, I'm declaring 4 classes. These are the same 4 classes that we saw earlier. We have our player, right? And then we have our warrior, wizard, and bartender, which all extend from player, because we created a player, which is our template. And then we created warrior, wizard, and bartender, which extend from our template so that we can have customized versions of our player that do different things. So for example, if our player has a walk method on it, so this is in the player prototype, our warrior, for example, has a charge method. Right? Maybe they can charge someone with their shield, for example. That's pretty common. But in this case, notice that our warrior also has a walk method. Now, this is kind of confusing, right? Because it's like, okay, well, player has a walk, but then warrior has a walk. So which walk are we doing for a warrior? Well, the answer is we do the warrior walk. Right? And I don't know what a warrior walk looks like, but in this case, if it's on the actual class, we're going to use it. But I'm going to mention what happens if it's not in the class in a second. Hopefully you can get what I'm trying to get at. Our wizard also extends from player, has a constructor as well. Instead of charge, maybe it has like a cast spell. Right? So wizards cast spells, but then also it has its own type of walk. So wizards walk in their own specific way. Maybe they walk slightly faster, for example, because they don't have as much like armor or something like that. Right? And then our bartender also extends from player, right? Has their constructor, but then their special function is that they can throw mugs at enemies, for example. Right? So they have all these mugs and they can throw them at the enemies. But notice that our bartender doesn't have its own walk method. Okay, does this mean that they can't walk? We'll find out, right? I'd like you to think, what is the answer to that question based on what you see here in these first 4 lines of code? Okay, so what we're going to do next is we're going to make 3 instances, one of each of these subclasses. So we're going to make a warrior, Genghis Khan here with HP, MP items and a shield. Then we're going to make a wizard, which is going to be Gandalf, 150, a little bit less health, more MP. Gandalf has a pointy hat, and then Gandalf's wand is an elder wand. And then we have a bartender. It's going to be Mo, and we have some HP and MP, maybe a little bit more balanced. And we have some items in there for Mo. And then Mo's item is a crystal mug, which is what he's going to use to throw mugs at enemies. All right. So we have our 3 instances of our classes. Now check this out. This here, what I'm going to explain next, is polymorphism in effect. So if we take all of these instances and, for example, let's put them in an array. So we have a whole bunch of players, or we have a whole bunch of enemies, or we have a whole bunch of something. We're going to put them in an array. I'm just, in this case, going to call it players. Now, what I'm going to do is I'm going to loop through players. In this case, just using a for of loop. You can use any loop. It doesn't really matter. But this is the key right here. This very simple looking line of code is doing a whole bunch of crazy stuff behind the scenes. Now, we can do player.walk. Now notice that each of these players that we're referring to here is one of the players in this list one at a time. So first it's warrior, then it's wizard, then it's bartender. So let's try to think of what's going to happen here. Okay, first we're going to do warrior.walk. Well, we're going to ask the question, does warrior have a walk method? Yes, it does. So we're actually going to call this walk method right here inside the warrior. We don't actually go to look at the player to find the walk method. This is already in the warrior prototype or the warrior class. Great, so that works. Then we're going to move on to wizard, which is our second one. We're going to ask, does wizard have a walk method? So we're going to come up here. We're going to say, yes. Oh, look, wizard has a walk method. It's right here. So we're going to do the customized walk for wizard. Okay. Then we're going to go to our bartender, which is the last player in our list of players. And we're going to do bartender.walk. We're going to come to our bartender class. We're going to ask, is there a walk on bartender? Well, there isn't, right? There is no walk. Our bartender only has a constructor and throw mugs. There's no walk on bartender. But does JavaScript give up at this point? We know that it doesn't, right? Because bartender extends from player. So JavaScript is going to look up the prototype chain, or in this case, the class chain, if you think of it from the object-oriented programming style, and we're going to look up at player. Does player have a walk method? Yes, it does. It's right here, right? So we are actually going to use the walk method on the player, which is the generic walk that every single type of player has, but we can actually what's called override it in the subclass if we need to give it custom behavior. So we can say that warriors and wizards have a custom walk method, so they have their own customized version of walk. But our bartender uses the walk method that's generic to all players that's inside of the player class or the player prototype. So this code here is guaranteed to work for us because in the worst case, if our actual subclass doesn't have the walk method, the prototype, or in this case, the superclass does. So we're going to default and fall back to that. And that is polymorphism. Isn't that awesome, right? Like, I think it just takes a little bit of appreciation to fully kind of think of all the possibilities for this. But what we can really say here is that we can guarantee that for any players, as long as we have a list of players, this could be 100 players, 1,000 players, 1,000 enemies, 1,000 of whatever. But we can say that they might end up using their custom version of walk or whatever method we give them, or they'll use the generic version, right? Which is awesome. So we can mix both custom functionality as well as generic functionality. And this is where the name polymorphism comes from, because this function or method technically changes forms depending on what the thing on the left of the dot is. So depending on what type of player that we have, we get a different walk, even though they're all technically players. So this is polymorphic, which is super, super cool. I'm going to show you a demo of this really quick just to wrap this up. So I'm going to create a new file here. I'm going to call this polymorphism.js. I'm going to copy over my warrior and my player from my subclass. Or I guess I can copy it over actually from over here. Let me do this over here from my right there. From my one I just did. I'll get rid of this player.prototype. I don't really need that anymore. I think that's fine. So to demo this for you, I'm actually going to add a speak method onto warrior. Okay. And in here, I'm just going to say console.log, and I'm going to, maybe I'll just add a whole bunch of exclamation points. Okay, so the warrior is just yelling all the time, and we just have a whole bunch of exclamation points all the time. Okay, I'm actually going to get rid of the super.speak in here as well, just so that we can really focus on the actual speak method from the different subclasses. what I'm going to do then is I'm going to copy my warrior and I'm going to make a wizard. And wizard, I think I had my wizard had a, where was it? A wand, and our bartender had a mug. So I'm going to say wand, and I'm going to say this dot wand is equal to wand. And they're also going to have a phrase, but then instead of exclamation points, I'm going to say magical or something like that, right? And then I'm going to copy this one more time, and I'm going to make a bartender. Right? I know there's a lot going on over here, and bartenders get mugs. Is it mugs? Did I say mug? Mug, single mug. One. They only get one mug. There we go. This dot mug equals mug. But I'm going to get rid of the speak function inside of bartender. Okay. There we go. So let's take a look at this really quick before we actually run this code, just to recap what's happening. Player, which is our base class, has a constructor, has a speak. We give it the speak, so we give it a phrase, and then it'll run this code here, which is going to console log out. This dot name says the phrase. So very kind of generic type of method. Then the warrior is actually going to do an override. This here is called an override. We're overriding the speak method inside of the parent class and doing our own thing. So here we're not going to actually say this dot name says phrase. We're just going to log out the phrase with a bunch of exclamation points. Same thing with wizard, right? Wizard is just going to do the same thing, but with a slightly different kind of spin on it. It's going to say magical instead. Bartender doesn't have a speak. So if we ever try to use bartender dot speak, it's going to refer to the superclass's speak. So let's create a whole bunch of these classes or instances of the classes. I'm just going to copy over Genghis Khan over here and bring that over. Then I'm going to say, I'm also going to copy over my my wizard here just so that we can actually see this and you don't have to watch me type all the time, and my bartender as well. All right. And I think I messed up something here when I copied this over, and that's a quote. There we go. Almost had it right in the slide. That's what happens when you try to code in plain text. So let's take a look at this. We have our warrior, right? Has all the values, but the only difference here is really the warriors have a shield, wizards have a wand, and bartenders have a mug. All the other values are the same. Name, they all have a name, they all have HP, they all have MP, and then they all have items. Just slightly different items in this case. They also have different names and different HP and MP, of course. Now, I'm going to say const players, and I'm going to make an array of our players. So I'm going to say we're going to have our warrior in here, we're going to have our wizard in here, and we're going to have our bartender in here. Okay. Now, this is the fancy part. I'm going to say for each player of our players array, right? I'm going to say player.speak, and I can give it a phrase, right? So I'm going to say I am speaking, right? Just like that. So let's see what happens if we do this. Now, I'd like you to think what is going to happen when we run this code before I actually run it, to see if you can test your knowledge of what you've seen from polymorphism so far. So when we're running through this list of players, which speak function are we calling for each of the players, whether it's a bartender, a wizard, or a warrior? All right, so let's run this and take a look. So I'm going to run node polymorphism.js and check that out. Right? Isn't this remarkable? So just to really hammer this home, when we have our three players, one at a time. Okay, we have our warriors first, second is wizard, third is bartender. So we're going to call speak on warrior first. Well, that's going to come to warrior, and it's going to use this override, which is why it's going to say I am speaking with a bunch of exclamation points. Then we're going to go to wizard, and wizard is going to run speak with I am speaking. And we're going to come up to our wizard class here on the prototype. We're going to pass I am speaking up to phrase. We're going to do I am speaking and then magical, which is what we get for the second log. Then for our bartender, Mo, which is our third and final player, we're going to call speak on Mo and give it I am speaking, right? And we're going to come up to our bartender class. We're going to ask, is there a speak? There is no speak. So we are going to look in the prototype or the superclass in this case, and we are going to come up to player. Then we're going to use this speak right here, pass it the I am speaking as the argument for phrase, and we're going to console log out Mo says I am speaking. Notice we actually even get Mo's name because that's what the this is in this context specifically, right? Because Mo is our bartender, which is the third item in the list. Isn't that super, super awesome? This right here is polymorphism. Okay, now I know this was a bit long, so I'll end it over here. I hope you found this video valuable and interesting. I really enjoyed making this video, and I've made a series of exercises next to actually practice this concept as well as inheritance, which is going to come up as the next video. If you did like this video, I'd love it if you could like the video and subscribe to the channel. I'd love to hear in the comments as well. Have you seen inheritance and polymorphism before? How are they kind of explained? Did you ever use it? Have you maybe used it without even realizing? Or is this the first time that you've seen these concepts? I hope these explanations and drawings and visuals made sense. If you'd like a little bit more on this topic, definitely let me know as well. But I'll leave it at that for this video, and I can't wait to get to the exercises next, where we'll get even more practice together on these two topics specifically for OOP, which is inheritance and polymorphism using JavaScript. I'll see you over there. See you later.